In this video, we'll talk about how to convert rectangular equations to polar form. So there are three formulas that we need to know. The first is r squared is equal to x squared plus y squared. The next is x is equal to r times the cosine of theta. And the last one is y is equal to r times the sine of theta. So knowing these three equations, let's work through a few examples. Let's say we're given the equation x squared plus y squared is equal to 4. So we would say that this equation currently is in rectangular form because it uses x's and y's as opposed to polar form, which uses r and theta. So how can we convert this rectangular equation to a polar form? Well, for this example, we need to recognize that x squared plus y squared is just equal to r squared. So this whole left-hand side right here can be rewritten as r squared. So we'll say r squared is equal to 4. And then we can simplify this a little bit further by saying, how can we get r by all by itself? Well, we could take the square root of the left-hand side and the square root of the right-hand side, because when we do that, we'll just be left with r. And the square root of 4 is 2. So r is equal to 2. So that's our final answer. That's how we can write this rectangular equation in polar form. Okay, let's try another example. Let's say we're given the equation x is equal to 4. This is currently in rectangular form because it uses either x's or y's or both. So how can we convert this into a polar form? Well, we need to write x is equal to r times the cosine of theta. So this left-hand side right here, we can actually rewrite this as r times the cosine of theta. And on the right-hand side we have is equal to 4. Now when we write it in polar form, we usually try to get the r by itself. So how can we get the r by itself? Well, if we divide this left-hand side by the cosine of theta, notice that these cosines would cancel out. And if we divide the right-hand side by cosine of theta, we'll be left with r is equal to 4 divided by the cosine of theta. Now, we could leave it like this if we wanted to, but in general, we don't really like to have trig functions in the denominator of a fraction. So let's see if we could simplify this. So if we wrote this 4 over the cosine of theta as 1 over the cosine of theta times 4, we can see that this 1 over the cosine of theta, if you'll recall from trigonometry, this is equal to the secant of theta. So really, this whole right-hand side can be written as the secant of theta times 4. So if we want, we can write our final answer as r is equal to 4 times the secant of theta. And that will be our final answer. That's how we could write this original x is equal to 4 rectangular equation in polar form instead. All right, let's try one more example. Let's say we're given the equation y is equal to x squared. How can we write this in polar form? Well, we'll start by replacing the x and the y with these equations. So instead of y, we'll write r times the sine of theta is equal to, and instead of x, we'll write r times the cosine of theta. And remember, this x is squared. So we can write r times the sine of theta is equal to, this expression squared would be r squared times the cosine squared of theta. And now notice that we have an r squared on this right-hand side and an r on this left-hand side. So what we can do is we can cross out this r and we can cross out the squared, so this just becomes an r. So we're left with the sine of theta is equal to r times cosine squared of theta. And remember, we said we'd like to try to get the r all by itself when we're writing polar form. So to do that, we can divide this right-hand side by the cosine squared of theta, and we'll do the same on the left-hand side. Divide by cosine squared of theta. So what we're left with is r, let's write the r on this side, r is equal to sine of theta over cosine squared of theta. Now, because we have a cosine squared of theta in the denominator, we can actually rewrite this as the sine of theta over just the cosine of theta times 1 over the cosine of theta. Because this cosine of theta and cosine of theta in the denominator, when we multiply those together, that would be equal to the cosine squared of theta. So notice when we write it in this way, the sine over the cosine, this is equal to tangent. That's the definition of tangent, sine over cosine. And 1 over the cosine is equal to the secant, just like we had in the previous example. So really, our final answer we can write as we'll write it over here, r is equal to the tangent of theta times the secant of theta. And that will be our final answer. That's how we can write y is equal to x squared in polar form.